Hello, my name's Tom. I'm a principal engineer at BT Group, and today I'm going to be telling you about the platform that we've built that allows our teams to get into production in under 15 minutes. Now, this platform, it's self-service, it's secure by default, and hopefully, as you'll see, it's a delight for our engineers to use day to day. So this originally came about as the result of a data center closure. So our TV team had a bunch of applications running in 2 on-prem data centers, and we needed to close one of those by the end of the year and move everything that's running there somewhere else. So there's a bit of a summary of where our applications were at this point. The majority of these are running on-prem, so not only applications, but also things like databases, message queues, all of the kind of core of our application estate. Then we've got a bunch of applications which are running on an on-prem Docker swarm. This is significantly fewer than are running on normal VMs, and there's still a little bit of manual stuff needed to get applications moved over to this Docker Swarm cluster. So it's not entirely kind of hidden and abstracted away from teams that are using it. Then we have a number of teams that have moved to AWS native services. So we're talking Lambda, DynamoDB, SQS. These teams are kind of isolated from most of these changes, but we need to make sure that we can easily talk to AWS hosted services from whatever platform we come up with to help our on-prem teams out. And then finally, we didn't actually have a super specific thing invented in 1994 that nobody knew about. But because this is a migration, we did need to worry about, those sort of things you've had running for 10 years, sat around on a server, working absolutely fine, but no one really understands the intricacies of anymore. So how do we go about solving this? Well, we had no mandate to say, you must use this new platform. We really approached it from the point of view that if we treat this like a product and really make it so that our engineers want to use it and are compelled to because it's the easiest way of doing what they need to do, then it'll be a success. So let's talk about the platform and how we assembled it. So we broke things down by looking at the process that our teams need to go through currently to kind of configure something and get it deployed into that on-prem world. But we don't want to just take that and copy paste it and automate a bunch of bits. We want to really dive deep into what are the underlying problems that each of these steps they currently go through is addressing. So first up, we need to create a VM, configure a VM. This used to be a Jira ticket off to an infrastructure team to go provision a bunch of stuff, wait a few days, come back, hopefully it was correct, and then you could carry on. But really, we just need somewhere for the application to run. Now, we selected HashiCorp Nomad for this. Most of our applications, we were aiming to containerize. So that's great, Nomad ticks containers, but it also gives us the flexibility to be able to run slightly weirder stuff that we might not be able to easily containerize. So whether that's like a raw jar file, whether it's like an IIS task, some native executable, Nomad will deal with that, and we can use the same abstractions that we use to deal with containers to deal with all of those weird edge cases too if we need to. Next up, the team would need to go and ask our firewall team to create a bunch of rules for them. This usually was where the majority of teams encountered issues because they'd need to find out a load of low-level stuff like the IP and subnet of the applications that want to talk to them or they want to talk to, when realistically they want to just specify this in language that's understood to them, right? So I'm application A, I want to talk to application B, ideally in a secure way. And we're able to do this by using HashiCorp Consul. So we use this for service mesh. We also use it to secure that communication using mutual TLS. So now as a team, I just say, talk to application B. The platform then handles all of the working out where that service is, configuring envoy proxies for mutual TLS. I don't have to worry about any of the mechanics of how that works. Then we need DNS records. In our case, prior to the platform, we'd have to go and either ask a team to create these, or in some circumstances, we can go to some web page, fill out a form, and then it will get created for us. But really, it's 2025. We can just get Terraform to deal with this for us. Then when it comes to configuring load balancers, we can also make this go away. We don't need a separate load balancer team to go type a bunch of stuff in. We don't need to worry about which load balancers to log on to sort anything out. We can just make this go away. So we're using Consul for our service mesh. We can use a Consul-aware load balancer. In our case, we're using traffic to kind of discover all the services that are running. And then based on the tags that we give them, just expose them to either the corporate network, to other AWS services via private link, or to the public internet. And as a user of the platform, I can just say, yeah, expose to the internet, expose to corporate networks, and the platform can handle the mechanics of, assigning the correct Consul tags to get traffic to pick this up. Application config is slightly more in the application team's control, especially with a migration. We want them to basically do as little work as possible to take their app that they've got running on-prem and put it here. So we want to give them flexibility in terms of being able to specify environment variables, include files, whatever they're currently doing, to make that process of moving from one to the other as straightforward as possible. But we do want to make sure that as we're doing that, we're improving the security and improving the kind of resilience of how we've got things set up. So we're using HashiCorp Vault for secrets. Again, as a user of the platform, I don't care that it's going into Vault, but it is. So I encrypt my secret, put it into a file that defines what my application needs. We then handle the lifecycle of that secret, putting it into Vault, ensuring it's securely included in the application. And for things like our Kafka cluster or assuming roles in AWS, we can abstract all of that away. So we literally say, what AWS role do you want to assume? Well, there you go, configure that in Vault, and we'll handle the rotation of that according to our security policies. Now, once we've got all this, this means that we're able to have a lot more mature conversation with our operations team. So before we had a bunch of bespoke, manually created stuff, which meant that when we get it into production, it's kind of, even if it's following a template, it is its own special thing. With this approach, obviously we've got automated rollbacks, we've got canary deployments, but most importantly, we've got that standardized deployment process and environment. Whereas something deployed to a Nomad job in a test environment is the same as something deployed to a Nomad job in a production environment. All of the process that goes along with it is also the same. So we're able to kind of nudge our teams and our operations away from the old school world of, we need to test this absolutely super thoroughly. We need slow batched deployments into more of a continuous, okay, yeah, we've got this. We know it works because we've shipped the same change 1,000 times before. And it also makes the whole process a lot easier for our teams because now we've got everything automated. We can use Terraform to provision 100% of this. So our deployment process just becomes literally a 3-line GitLab CI file they include in their project, and that's all managed by the platform team. So this all sounds great. Let's have a quick look at a demo to give you an idea of what it looks like for our teams. Cool, so here I've got a very straightforward application. All it used to do is say hello world, and we're going to change it to say hello PlatformCon. We're going to grab that greeting from a service created by a different team called the greetings service. So our application here, to define our application, we don't need to know Helm charts, we don't need to write a Nomad job, we don't need any of that. We just literally define stuff that our application cares about, or we care about as engineers of our application. So here you can see we've got a count of 3. We're exposing it to the public internet, to all IPs, so we could limit that if we want to just corporate networks or just particular IP ranges. Then I've got a health check. So we need some way of the platform knowing that my application is healthy. But the interesting bits for our change are these 2 things here. So we've got our upstreams, and as we were saying before, we don't need to care about where that service is or anything now. We know it's called the greeting service. It's in the same namespace as us. So we're just saying talk to greeting service. And then getting that into our application is not special. It's just an environment variable, same as it might have been on-prem or whatever. And we just reference the fact that we're going to talk to the greeting service, which we've defined. So pretty straightforward here. The other thing that we're going to need to deploy our application is just a GitLab CI file. As we mentioned earlier, that's just literally 3 lines. So that whole process of deployment is managed by the platform team. We just include the template called auto build. It's going to find out what sort of project it is and pick the most appropriate GitLab CI jobs to run. So let's commit that change, and then we're just going to push that up to GitLab. So head over to the merge request now. You can see our pipeline has started. So nothing fancy we needed to do from a CI/CD point of view. Whilst that's running, let's just head over to our documentation. So as we'd expect with any other consumer or like off-the-shelf product, we need pretty good documentation to support that. So for example, our ls-vars file, as an engineer, I can come in here. I've got a comprehensive documentation on all the different options that I can set in there, along with examples. So for example, our upstreams, our environment variables. And then I can also see, if I've never used the platform before, how to get started. So as you see, just a GitLab CI file and then our ls-vars file with our options in. So that pipeline is now passed, which is great. So I've got a review copy of my application deployed. So that's not going to interfere with any kind of stable test environments that we might have up and running. So I can go to ShipDoc, which is our kind of sidecar tool. That shows me all the information about my deployments. In this case, I've just deployed something that's available publicly. So I've got a public endpoint for that service. I can paste that in, and here you can see we've got our hi PlatformCon, and that's going to go off to that greeting service every time and fetch a new distinct greeting. So you can see as we're refreshing here, we're getting a bunch of different greetings, which is great. So this is deployed now. I didn't have to worry about the mechanics of how they got deployed. I just literally used that ls-vars file to define the characteristics of my application. Now, as I mentioned, this is a review deployment. So we can see here, I've got our, if I switch back to this tab, I've got our existing stable test environment up and running. I can refresh this as much as I want. I'm just getting hello world back. So that means that anyone that's interacting with that from other teams to do integration tests or to run like a test environment people can interact with is not impacted by this change until I'm happy and tested it and it can go out. Okay, so how did we get on? Well, in terms of reductions, we've taken a process that used to take multiple days and reduced that down to, best case as little as 10 minutes. And we've taken what used to involve 3 teams and empowered 1 engineer from an application team to now take their change all the way through into production, regardless of if that application has ever existed before, whether it's got existing infrastructure, they can now manage all of that on their own. In terms of statistics, we've got 540 services registered in Consul. Now that includes things that are running on-prem, which means that our teams get the same experience of talking to other services just by, knowing their names, whether that service is running on-prem or running in our platform. We've got 245 Nomad jobs registered, and we've also onboarded a bunch of other tenants. So originally this started as a migration for the EETV team. We've now seen EE Marketplace come on board. We've got some internal security tooling, and then all of the internal platform applications also run on the platform. So, we have to make it work because we're using it ourselves. The most important thing, though, is what our engineers think. So talking to Matt from our EETV team, he is hugely praising the platform in terms of the way that they're now able to bring services into production much more quickly. And then Adam here, showing that the platform is really allowing teams to focus on writing applications rather than a bunch of associated infrastructure and mechanics of how they get those applications out into the wild. So why did this work for us? I think the main thing is that focus on developer experience. We're not saying, look, this is a platform, you now need to know all about platform engineering. We're saying, look, we want to allow you to ship your applications in the best possible way. Let us handle that. You just write the code that you want to write and everyone will be happy. Secondly, picking sensible and secure defaults. You don't need to know a whole bunch of intricate detail about which policy means that this has to be set to this value. You can literally just deploy your application. And by default, we're adopting all of our organizational best practices and wrapping up, secrets management and everything for you. And then thirdly, because this was a migration, we actually got a lot of benefits from being able to get really quick feedback from application teams. So instead of this being like, oh, there's a nice platform, use it if you want to, because there was a big impetus to move applications, that meant that if things weren't working quite right, we instantly got feedback being like, oh, this is blocking us. This meant we could rapidly iterate on this and kind of ship new features and tweaks as we're going along, rather than it being, sort of like, oh, here's this thing, use it. So that's been a very quick look at our platform. If you're interested in talking more about platform engineering, drop me a connection request on LinkedIn. But thank you very much for your time.